Well, let me say a couple of things in response to Myo's um, introduction. Um, all of those positions are simply a place to do things. They're nothing in and of themselves. So it's been my good fortune throughout my career to be in places where I could actually um, pursue my interests in understanding how earthquakes and volcanoes and tsunamis and meteorite impacts, how they work. And I love to tell geological stories. And that's that process or those projects are really what motivates me and trying to excite other people to carry the torch. So that's why I'm here today. I want to tell you two stories basically, but all about tsunamis in Aceh. And I chose this topic even though it's not in Myanmar, like many of your other speakers chose Myanmar topics, because I think that once you get back in control of your country, you'll have lots of opportunities to do some very interesting archaeology and stratigraphy that relates to your historical hazards, whether they're earthquakes or tsunamis on the West Coast or the eruption of Mount Popa or any number of other things that flood histories and so on. So I'm hoping that even though I'm talking about something way outside of Myanmar, that the topics actually you'll see that they can actually be used to pertain to telling exciting stories about past events in Myanmar. So I'll not belabor all the co-authors here. We have archaeologists in yellow, we have a historian in green, myself, and our Indonesian Achenese collaborator, Nazi Ismail, and then Charlie Rubin, who many of you know. Let me just start. This spray paint on this home in Aceh it says the family of this room is still missing. So the emergency workers were still looking for the family, and probably in all likelihood, they were one of the 90,000 people in the capital city of Banda Aceh who perished because of the earthquake. We've made good progress in the past 20 years since the 2004 tsunami to figure out how often they've occurred, how big they have been, how regular they've been in space and time. We still have a lot of progress to make, but we've got a long ways. And obviously it matters, answering these questions matters to those living on the Indian Ocean coast. So we're using evidence from corals and sediments, sands, and from the remains of ancient communities, like we've started to do in Myanmar, right? Wang Yu and Bruce have been working on corals. Wang Yu's been working on sedimentary faulting through the old Mon castle or fortress in the Mon state. And there's lots of potential for looking at your ancient communities, their archaeological record, and what that tells us about floods on the Irrawaddy or earthquakes and such. So let me just start then this particular story. The colored patches there represent uplift and subsidence that occurred on the islands and offshore during the Great Earthquake. And as you probably know, the rupture was 1,600 kilometers long. It went all the way from southern Aceh province all the way up through the Andamans and Nicobars and all the way to the very southernmost islands of Myanmar. So it was a very great rupture. The blue areas show subsidence and the hot colors show emergence. That, of course, displaced the sea surface, which then caused a tsunami to hit the coast of Aceh and actually much of the northern Indian Ocean, including Myanmar. We started looking at evidence for old corals that had been displaced or lifted earlier. And Aaron Meltzner, who did his PhD thesis here in Aceh, he found evidence in 1394 and in 1450 for two big uplift events on the very southern part of the 2004 rupture. So that suggested a doublet, 60 years apart roughly, 55 years apart, about 600 years prior to this big 2004 tsunami. And we found evidence for nothing else in between. So what's that, about 600 years between big earthquakes. So today I'll present archaeological evidence that there is indeed evidence for tsunamis associated with those two coral uplifts. The 1394 tsunami destroyed 9 settlements along the northern Aceh coast. It profoundly influenced the economy and the history of the region. And that nearly a century passed before the coast began to be resettled. So the people whose communities were destroyed were largely killed, or the survivors moved away from the coast. And then someone came in and said, wow, what's all this wonderful land not occupied? We should occupy it and build ourselves a society. So they did. They became the Achenese. I'm also going to present a second story from a cave south along the coast from this house, about 60 miles, that contains 14 paleo or Holocene paleo tsunami sands and boulders. And the dates that imply a recurrence interval of anything from less than 100 years to on the order of 1,300 years. And I'll present stratigraphic evidence that the size of the tsunamis was markedly varied, and try to tie together, are the recurrence intervals tied to how big the tsunamis were. All right, so by 2015, we added to the story that Aaron figured out with the uplifts of the corals, and we found evidence in on one little island, one little peninsula east of Banda Aceh for probably the 1394 tsunami. So here's one site. There's a little boat that washed up on shore there, and it's sitting on the Holocene, mid-Holocene beach ridge. And above that is a section of sediment that includes human material. So here's a little sketch, a little stratigraphic sketch of that that exposure. And what we see, let's see if you can you see my cursor? Yeah? Can you see my cursor?
Yes, we can see well. Yeah.
Here's the mid-Holocene reef, and here's some well-sorted beach sand. And then somebody dug a big pit here, a couple meters deep, and they threw their trash in it for many years. And so that trash has dates here, 1200 to 1300, 12 to 1250, 12 to 1270, and so on. All these are radiocarbon dates on bones and charcoal and whatnot. And here is a coral date. And this is from a coral that's very fresh looking, that was put in the foundation of this lime plaster floor, which had wooden posts going up to hold it up. Something wooden was up here. And here's the floor. And in the base of that floor was a very pristine coral that dated to the date. Where does it date? Let's see here. Well, it dated to 1366 plus or minus 4. So probably this means that this was built somewhere around 1360s, 1370s, only to have it destroyed by the tsunami, the deposit of which is right here. These are corals here and poorly sorted sand. Lots of foraminifera in this and the overlying alluvium, and then in this man-made rampart, probably built to protect themselves from the Portuguese in the 1500s. So who were trying to invade. So here's another place. That site was right here. Here's another site right here. Here's a Japanese bunker that was built to so the Japanese trying to keep everybody else out after they'd overrun Sumatra during World War II. And in this place, there's another tsunami record shown here. And that record mapped out shows 2 layers of coral here and here with intervening alluvium. And the dates, radiocarbon dates, are in the red triangles, and coral dates are here. This is a slightly weathered boulder of coral that uses a date of 1344. The weathering allows us to infer that, in fact, these tsunamis happened in 1394. So we have pretty good evidence that something in the late 14th century, probably the 1394 plus or minus 4 date that Aaron determined on the coral boulders, or the coral reef out on the islands. So we probably have a doublet here, this one and this one. But we hadn't, so this is probably 1450, and this is probably 1394. We can't say that for certain, but the dates certainly suggest it. Okay. All right, so now just a little bit of cultural background here. Whoops, let me go back. This part of Sumatra, northern Sumatra, was very important for the maritime silk trade. So the Chinese were, for probably 2,000 years at least, were coming through here, going to India, and then going up the Red Sea, and actually trading with Arabs, who then traded with Europe. So, you know, the Romans had cinnamon. The cinnamon didn't come from Italy. The cinnamon came from over here in Indonesia. So the trade was two ways. And here we are along the northern coast, a key, everybody had to pass by the northern Aceh coast. If you're coming from India, it's the first place you can load up on fresh water. If you're leaving from China or from Java, it's the last place you can get fresh water for making the voyage across the notoriously dangerous Indian Ocean. All right. So the two tsunamis that we've documented in the 15th century must have had an impact on trade during that time. So we're going to take a look at the evidence for that. So here's a place that a place called the Lambaro Headland. This is a place that I showed you just before, where we had the two deposits of coral from tsunamis. And all of these places here are individual places where we found pottery. All these yellow dots, there's something like 1,000 places where we were able to retrieve pottery. And it's interesting that the pottery is not associated with any known buildings. All we have is the pottery. And when I first was here in 2007, I asked an archaeologist who was showing me some of these sites, why is there so much pottery here in the fish ponds? Why are they dredging so much pottery out of the fish ponds? And he said, well, probably a boat they damaged their pottery and they threw it overboard. And I said, well, couldn't it be from a tsunami? And he said, well, I've never thought about that. And so we started looking into the possibility. And we recruited, after the building back of Banda Aceh here, there are 30 Achenese who wanted to work with us, learning to be field archaeologists. So my colleague Patrick Daly from the US, he trained 30 Indonesians to become field archaeologists in a matter of a few years. And they surveyed very intensely with GPS and digital notebooks and everything, all these sites, and carefully recorded where everything was. So the dark area shows where we actually scoured the landscape. We didn't go all the way back here, but we did, like I say, 1,000 spots. And here's what we found. Over here, 60,000 ceramics. 60,000 ceramic sherds. This is a lens cap, so don't be fooled. That's my ceramic right there. That's my Nikon. So some of these are Ming Dynasty, some of these are Qing Dynasty, some of these are Dutch, some of them are Burmese, some of them are Thai, some of them are Japanese, and some of them even go up to the Dutch period. Over here on the left, these are all grave markers, and they're grave markers that have several distinctive styles. Some styles from the 1400s, 1300s, 1200s, some styles from the Achenese period, starting about 1450, 1500. So there are about 5,000 of these that we see in the intertidal zone. It's on a delta and sinking, okay? Plus there are tsunamis that come in. So these were all washed over by about 7 meters of water during the tsunami in 2004. So these are also sitting there just dissolving away, and nobody was doing anything with them. So we collected all these sherds and we took rubbings of many of the grave markers, and many of the ceramics are highly diagnostic with respect to source, age, and their use. So we can establish the size and the nature and timing of human settlements along this coast. You know, was this a shop? Was this a home? Was this a fixture from a boat? And when did these Achenese who were buried, when did these people die, and so on? What were their names in some cases? So here's a map that shows, it's the same map, but this shows the positions of sites that were active between 11 AD, 1100 AD, and 1390. Whoops, what did I do here? There we go. So you can see that there's big communities over here at Lambaro on the headlands, 20 meters above sea level. There's a big community here. There's a big community here. Nothing over here. There's a good sized community here, and smaller communities here with not as many sherds. Bigger community here and bigger communities over here, where Banda Aceh currently is basically this whole area. We couldn't look here because they developed it so much we couldn't see underground. The pottery's all gone or buried. So that's pre-1390. It looks like there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thriving communities along the coast. Here's what the sherds look like from the period between 1390 and 1400. Almost nothing. So something happened in that period that basically destroyed those communities. So that's pretty strong evidence that, in fact, the tsunami of 1394 and the tsunami of 1450 wiped out the northern coast of Aceh like the tsunami of 2004 did. And the only place that still had a relatively thriving but diminished community was over here on the Lembaro headlands. And that's the only place of all these communities that was above the limits of the 2004 tsunami. So they thrived only because they were above the limit of the tsunami, but they were clearly devastated because the number of sherds diminished greatly. All right. What about from 1550 to 1650, which marks the rise of the Achenese sultanate? So these people share customs in terms of their dress, in terms of the way they cultivate and prepare rice with Vietnamese and with Chams, who currently live in eastern Cambodia. So and their language is similar too. The Achenese language is not as similar to Indonesian as it is to the Cham language in Cambodia and Vietnam. So they must have come down sometime after the tsunami. It looks like maybe starting 100 or 50 years after the tsunami, and found a coastal plain that was very cultivatable in rice, and that was a great place for stopping on your way to India and Arabia or on the way to China. So they established a very powerful political entity, the Aceh Sultanate, which persisted all the way until what? Till colonization. In this case, not like in your case by the British, but in this case by the Dutch. And the Achenese were fierce fighters and the very last to fall to the Dutch, and that was not until 1871. So just before the British took over northern Burma. So you can see there's quite a political change here because of the tsunami. There was quite a horrific story of the wipeout of the previous culture, like in 2004. So now between 1650 and 1800, these areas have far exceeded their size in previous centuries. So they were setting themselves up unwittingly for their future generations to be wiped out in 2004. Let me go to another story now. We've just talked about the last 600 years of tsunami history. Let's see if we can extend it still further back. About the same time that we started working on the archaeological project, we also started working on in a cave that is only about, let's see if the next picture shows where it is. There it is. It's about 10 meters high. You can see the postdoc here walking along about 1.5 meters high. So 10-meter high entrance. It goes back about 80 meters. Its floor is about 1.5 meters above mean sea level. So high tide doesn't get here. So this never floods during high tide. And the vegetation trim line from 2004 is 24 meters above this. So this is a limestone sea cliff, and it was the wave came in full of sand and debris and full of people and shot into the cave, filled up the cave, drained back out, filled back up again, maybe 4 times in the course of about 2 or 3 hours. And in doing so, it brought in a lot of marine sand. It brought in a lot of shallow estuarine and riverine sediment and coconut trees and so on. So here's a map that we made with what's called a total laser station. I don't know if you have those in Myanmar, but they record about 50,000 points per second. They spin around like this, and they use a laser to make a map of the ceilings and of the walls and the floor. So here's a map of the floor. And the floor, the highest elevations are shown in hot colors here. Here's a rock fall, for example. All right, and here's a little rock fall. And then the cold colors are areas that are lower. So these have little ponds in them here and here and here. And those ponds seem to fill up when it rains. They fill up a little bit and they drain back out and fill in and then drain back out. Over on this side is a thick section of sediment into which we dug pits, pit 3, pit 1, pit 4, pit 8. I'll show you an excavation we did here that shows the boulders from 2004. All these pits in here, and then one finally over here. So here's the entrance to the cave. You'll see next to the profiles we made here from the survey, the cave entrance, cave mouth, across the rockfall, and then across the sedimentary section that we investigated. So here's the mouth, 10 meters high, shaped about it like a circle. There's this, we made this, the floor, the zero datum. So here's the zero datum again, halfway in. Here's that rockfall, coming off this irregular ceiling. Boom. That, the edge, the sill of that rockfall is actually a ½ meter higher than this. So this makes, this allows you to have a pond about a ½ meter above the sill back in here, back in the cave. So here are all the strata. There's pit 4, there's pit 2. I'll show you examples of pit 1, which is almost here. And you can see every bit of sediment is below this point right here. And it's all below the cave sill. You can see that this could be ponded then. All right, so dynamic models of the cave filling say that twice in the first hour or two, the cave filled basically to the top, totally full of water. So 10 meters of water, 6 meters of water here. Here's a shot of the cave with with Nasli, our Achenese collaborator. He doesn't want us to call him Indonesian. He wants us to call him Achenese because they have political problems like you guys do. Theirs were a lot more long lasting than I hope yours will be. Their political problems lasted in Aceh from 1871 to 2005. The tsunami finally got everybody together and agreed to call it quits and stop fighting each other. So here's a pit we excavated. This is pit 1. We'll see in a minute. There's the mounted debris we excavated, all done by farmers who we hired. Here's a shallow one that shows we took away the sand from the 2004 deposit to see the boulders that were brought in. Now those boulders cannot move unless you have water moving at least 4 meters per second, up to 6 meters per second. And that's what the modeling of the tsunami shows in this cave, that waters were at maximum moving about that fast. Just for reference, if you're in a tsunami, if you go to the beach sometime, if you're in a tsunami on the beach, you won't be able to stand if the water is surging past your knees at 1 meter per second. You won't be able to stand. It'll sweep you right off your feet. So 6 meters would be enough to move almost anything. All right, so here's a picture of the wall of pit number 1, back in here. And what you can see is a whole sequence of interesting stratigraphy. It reminds me of back when I did my PhD thesis in California on the San Andreas Fault. We had black peats from marsh and then river sands and then more peat and more sands, channels and so on. So this is also similarly colored. And for that, we have to thank the bats. So there's lots of bats on the roof of the cave, and they don't like it when we're working there with our neon lights and so on. And so they're always peeing on us and dropping droppings on us and flying out when they're disturbed. So let me show you some of the stratigraphy just so you get an idea. This is 2004, and we've messed it up by digging around. So this is not a very good exposure of 2004. I'll show you a little bit later. But you can see it's on a clearly erosional surface here. It cuts out lots of sediments. All these guys here are gone. The white numbers are the numbers we give the sediments. The younger, the higher the number, the older the bed. So these little blue dots are clay pebbles that are ripped up off of this bed. So tsunami comes in. The first thing that happens is it rips up a bunch of cobbles from the existing sediment, deposits them along with the marine sand or estuarine sand. Then a period of repose occurs where not much happens except a little bit of motion along the surface by some trickling water and bats putting their excrement on the deposit to make it blacker. Then there's another tsunami. There's a pond here. This is a pond, a mud, and that mud is cut into by this tsunami deposit, unit 4243. And the first part of that tsunami deposit is a breccia. So it represents erosion, deposition of the eroded material with the marine sand, and then laminated beds here, which indicate upper flow regime, which indicate probably flow of at least 1 meter or so per second in the latter stages. So there's one big tsunami. Here's a tsunami. Whoops. Then we have keep hitting the wrong button. Then we have another tsunami. Well, then we have another pond. This is another clay. And you see the fractures. The fractures contain material from above. So probably there was earthquake shaking after this was deposited. After this was, part of this was deposited, associated with this unit 56, which is another tsunami deposit. So probably an earthquake. Before the tsunami deposit arrived, these guys sank down into these fissures in this clay. So, and then we have so there's a detachment along here. This red thing is actually a detachment that makes these little anticlines and synclines. Whoops. Okay, then another clay came in, big thick one. This is another freshwater pond, and that probably took a few hundred years to form. And then we had another big tsunami, actually about the same size about the same volume as the 2004 tsunami, rip up clasts here in orange that I've colored from unit 58. You can see where it got taken out here, and out. In some places this is completely gone. All this clay is gone. So this is a very powerful, very thick deposit, as thick as 2004. Then there was a long period of quiet water movement of materials across the surface from leaks in the cave roof during floods probably, but fairly quiet water deposition, along with more of the bat poop, okay? Then another tsunami, whoops, another tsunami, unit 73, 74, another tsunami, 75, another tsunami way up in here, 712, another tsunami here, unit 82. And we're going here from about, 7,000 years ago down here to about 3,000 years ago there. And then a big unconformity, which tore away several other tsunami deposits that we can't really see in the cave. So there's a gap in the record that we haven't dated well, from about 3,000 to about the present. All right, so let's take a look now. Let's put all these tsunamis back up and see. Well, actually, I'm going to show you a couple of examples first. I think I still have some time. I don't know if you guys can see it, but I can only see part of my screen because of all of our pictures and stuff. This is the lower part of the section. The tsunamis are numbered with Roman numerals: 1, 2, 3, 4, 5, 6. We're at 6, 7. And then I'll show you the upper part of the section later. So all the white lines are my mapping, which took a long time. We used photomosaics, like Ray sort of made famous back after he did his PhD at Caltech. And there are chunks of cave florets, little flowers of chalk that grow out of the limestone on the ceiling of the cave. And if they usually fall and they don't get reworked. So you can see some places where they're pristine. Not very many. Actually, here we're actually in a tsunami deposit. Here's a tsunami deposit, and it fell but wasn't eroded. Here's a non-tsunami deposit that has a pristine floret. In most places, though, they're eroded. So they fall off, they get rounded into a little pebble or a little sand grain, or are absent. So you can see here where they're absent, you can see where they're eroded, and in most places they're eroded. So that's some indication of violence, of transport. There are foraminifera counts shown in yellow, and you can see here 229 per cubic centimeter, 0 per cubic centimeter, which you'd expect in a non-tsunami sand. So forams mean that you have to actually brought things in from the ocean. In this deposit, which we don't know the source, no forams at all. Here 20, 40, 60, 34, and so on. Here's the next section, the next higher section, unit 73 through 2004. And you can see here we have some very high numbers, up to 2,500 forams per cubic centimeter. That's a lot of forams. And then we also have some places where there are 0, even though it's a tsunami deposit. All right, so we've done a fairly careful job of both granulometry and foram counts and looking for the cave florets. Now let's take a look just at the 2004 deposit to see what we can learn about what the sediments tell us about the actual tsunami itself. Here's a model that one of my co-authors made, Jose Barrero, who's a tsunami expert. of the tsunami as it hit the mouth of the cave. This is the elevation of the mouth, approximately, well, of the rocks, the rockfall sill. It's about 2 meters above sea level. So anything that goes above this was able probably to send water into the back of the cave and deposit sediment. So here, during this period, from about half an hour after the beginning of the earthquake to about an hour or a little less, the cave was basically full and then drained. And it filled in a matter of about 15, 20 minutes, and it drained in about 15 or 20 minutes. And it drained completely, it turns out. So it would have brought in sediment, eroded the base, as you saw, deposited the boulders that you saw, or you'll see some more of later, and then drained back out, but it left a pond behind the rockfall. And that pond was about, a half meter deep over the initial deposit. A little guy came back later, may or may not have actually gotten back past the rock sill. But then here's a big filling around 2 hours. And that filling also drained for the next minor filling and before the next minor filling. So do we see evidence for 3 different surges in the 2004 deposit? Let's take a look. So here's just one of many excavations where we didn't destroy the deposit by digging around. And here are older deposits. There's a big scour right in here. It's all eroded. This is basically a fining upward sand. 3,000 forams in here, 3,000 here, 2,500 here. These are all fining upward cycles, here and here, here. And all of these are major contacts, most of which are erosional. So there's evidence here possibly for as many as 1, 2, 3, 4, 5, 6 separate surges in here. Okay, so it's roughly consistent with what we'd expect from the dynamic modeling that that we've done for water surging into the cave. Those dynamic models suggest the movements were in fact anywhere from a meter per second to 6 meters per second. In this particular case, there are no boulders for some reason. Here are the boulders. So here's one of our pits with lots of layers in it. Here is Patrick, my co-author. Here he dug a pit where he just removed all the sand from 2004 until he got down to the unconformity. And look what he found, all these boulders, just huge numbers of boulders. And these require velocities of 4 to 6 meters per second. And they're about 20 meters into the cave from where the rockfall was over here. All right, so there's a lot more I could tell you, but I'm afraid I would bore you and I'd probably fall asleep because it's late at night here right now. So let me just wrap things up with 3 or 4 more slides. I've tried to, based on the thickness of the sediments and whether there are boulders or not, whether their base is erosionally deeply scoured or just to some small degree scoured, I've tried to make an initial assessment as to the relative sizes of the tsunamis. So tsunami 1, about 6,500 years ago, okay. Looks like it was a relatively small tsunami. It didn't do a lot of erosion. It didn't deposit a thick sand. These guys, I would say, are big. These 2 in here are actually quite small. They did almost no erosion of the base, almost no erosion of the thin little peats and sands. So these, I think, were pretty small. And it looks like they might have been pretty closely timed from this one. So a small little event, a small little event, a moderate-sized event, and then a really big event. But after that big event, after that big event, there was another moderate-sized event, a big event, not quite as big as this one. And we think the date might be over here, but based on the radiocarbon dates, it could be anywhere in this range. So it might be that after this really big event, there was a 1,000-year hiatus. Or that hiatus could have been between this one and this one. So 3 moderate events, all of which seem to be pretty closely timed. If you take these as evenly spaced, they're about 190 years apart, whereas these are about 325 years apart on average. Okay, now, so one question would be is this a 1394 type event and this is a 1450 type event? And they're really only 60 years apart, but this one's, or were there three? Was there a triplet all within a matter of 100 years? In any case, the time between these can't be much more than, these are 500-year grid marks, so they couldn't have been much more than 500 years apart, right? And maybe just maybe even less. Okay, so then here's the part of our record that's not all that great. We do have evidence. This is that last tsunami, Unit 82, just the last tsunami before that big erosional hiatus. And these guys are ones that we can see in just a very few places in the cave. And the dates, there's only one date that constrains all three of these. It's a date from here, and or a date from here. And they could be anywhere from 2,700 years ago to the beginning of the historical period, to 1494, really. Well, Patrick drew the letter here, but I would draw it there, or 500 or 600. So there can't be, none of these three earthquakes can be less than 600 years from 2004 because of the archaeological record I showed you, right? All right, so this is the first cut. We're still working on this paper and hope to submit it by the 20th anniversary. All right, so our hypothesis then is that the higher and stronger tsunamis produce a thicker and coarser deposits. And we think that if we look in more detail in the future at the stratigraphy here, and we do the sort of detailed sampling that we did for the 2004 tsunami, we might actually be able to produce tsunami hydrographs for each of those tsunamis. So for example, these really small ones, I'm betting that because they produced almost no erosion back in the back of the cave, and because they are fairly thin and they don't have boulders in them or even pebbles in them, I'm guessing that they were, the height of the tsunami was just enough to get over the rockfall and flood the cave and deposit some sand. So future work, if we go back here, could help us to refine this story. So we have three plausible modes of failure for the cave. The cave is here in the red dot. All right, so there was big submergence offshore, subsidence offshore at the time of the earthquake. There was big uplift here, and that uplift was probably associated with the rupture of a little back thrust called the Aceh back thrust, which we can see in the marine geophysics. And it's been quite a puzzle why all the calculations say that this tsunami should not have arrived at the coast until a half an hour later after the rupture started. In fact, it arrived 17 minutes after. So maybe this thing broke and it sent the tsunami into Aceh in half the time that you would expect from the megathrust. So one possibility is that the cave records big megathrust ruptures plus Aceh backthrust ruptures like 2004. Okay, another possibility is that the megathrust breaks all by itself and this doesn't break. And if that happens, you don't get as much energy, you don't get as big a wave down here on this down here. So that could explain maybe why some of them are big, but not biggest. Another possibility, which I think is quite plausible for the smaller tsunamis, is that you have piecemeal rupture of the megathrust. It doesn't all go at once. And so, you know, like your, when was your big megathrust rupture? 1770? Wang Yu and Bruce worked on this with you guys, right? Anyway, that has an out of sequence thrust as well. So maybe we have a series of smaller earthquakes breaking the megathrust in little pieces or on secondary faults, and that explains some of the smaller tsunamis in the cave. So here's my concluding thoughts then, or questions to myself is, will the next tsunami closely follow the 2004 tsunami? That is, like the 1450 tsunami did following the 1393 tsunami, only 60 years later, in which case it makes a big difference, doesn't it, whether it's going to happen 60 years later Or is the next tsunami a millennium away? Will it happen in 3004, 3004? In which case we can go, who cares? That matters a great deal to the current inhabitants of the Aceh coast, and we're developing strong evidence that it could be either. So it's going to require still some more work to figure out what actually is going to happen next. Thanks. Here's all the scientists getting excited about the layers. So here's 2004 before we scrambled it up. Here's the wall of the cave, and that's tsunami 82 and 83, which is one of the big ones. Here's the biggest one, this one in 2004. So that's about 5,000 years ago. And down here at the bottom is the cave wall that dips up to there. So here's the guy who currently runs the Earth Observatory. Here's a Polish fella, Jan, who did almost all the legwork. Here's Patrick, who did the geoarchaeology study with the 30 Indonesians. He's an anthropologist, archaeologist, sociologist. He's written a lot about the post-tsunami development. And then here's Charlie Rubin, who I hired as the chair of the Asian School of the Environment. And he's retired back to the same state I am, in Washington State, in the Pacific Northwest. And I spend my time writing more papers, and he spends his time skiing. Who has a better life, huh? Thank you very much.